Hello viewers, welcome to my channel. I'm Hasham Khan. So now I'm going to start a new topic in the subject statistics for management. The new topic is sampling theory. Before this already I have uploaded the videos on the basics of statistics like measure of central tendency, measure of dispersion, measure of skewness, correlation analysis, regression analysis. All these topics I have covered. So if you have not watched the earlier videos, I suggest you to go to the playlist of my channel. Select the subject statistics for management. Watch those videos, get a good grip on the topic of this subject, statistics for management. Now in this video, I'm going to start a new topic which is very important. That is sampling theory. This topic is very important because the coming videos are based on this sampling. The coming videos are the problems on large samples, small samples, chi-square test, ANOVA. All these are based on this sampling only. The procedure will be followed on this sampling only. So this video, don't skip in between. Watch the video till the end to get the complete grasp on the topic of sampling theory. Take a screenshot of the points which I have written on the board. Then I'll start explaining about the sampling theory. So first of all, the contents to be covered in this topic are first basics of sampling. I'm going to explain you what is sampling, why it is necessary. Secondly, sampling procedure, what are the steps involved in making sampling. Third, random and non-random methods of sampling. Then sample size determination, sampling distribution, standard error. Then central limit theorem, hypothesis testing, statistical estimation, point and interval estimation, properties of good estimator, confidence interval, large sample test, that is Z test. That means test for 1 and 2 proportions, test for 1 and 2 means, and test for 1 and 2 standard deviations. So lastly, this large sample test are all problems. Up to 1st to 12th, completely theory I'm going to explain. In examination, you may get a theory concept. That's why listen with full concentration. Watch the video with full seriousness. First up to 12 are theoretical. Then from here, I'll start the problems. Large sample test, that is Z test. Now, first of all, what is the sampling theory? The meaning, basics of sampling. Statistical data may be collected by complete enumeration or partial enumeration. When we need the statistical data, we can collect all the data, each and every item of the whole universe or population. In statistics, the whole is called population and the part of the whole is called sample. So how to collect the statistical data? Two methods are there. The first method, complete enumeration, that is also called census. That means each and every item of the population are selected for our consideration. This is census. And the alternative method is collect only a part of the whole. Collect only a part of the whole. Select only a part and give the opinion about the whole. Give the judgment about the whole. So the first, when you enumerate completely, it is called census. When you enumerate only a part of the whole, it is called sampling. So here in census study, each and every item of the universe or population is considered. While in sampling, information is collected about a small number of items which are representative of the whole. This is the difference. This is the difference. When we select each and every item, it will be called complete enumeration, census. When we take only a part from the whole population, it is called sampling. If the samples are representative, properly drawn and interpreted, then it is most likely that the conditions of the whole. It represents the most likely conditions of the whole. See here, when we want the information, when we want the complete data about the whole, if the sample is representative, if the sample is reliable, then the conditions of the sample will be equal to the conditions of the whole. That means instead of studying the whole, we are studying only a part. And this part is a representative of the whole. Then the total number of members of the population is called population size, whereas the number of members in the sample is called sample size. Two sizes we have, population size and sample size. Number of items in the whole population is called population size, and number of items we have selected in the sample is called sample size. Then the primary objective of sampling is to obtain the maximum information about population with a minimum of effort, and also set out the limit of accuracy on estimation based on sampling. First of all, why this sampling is applied? What is the objective of sampling? The objective of sampling is to get maximum information about the population from the study of sample. We don't have so much of resources, so much of time, so much of effort to study the whole population. So if we systematically select the sample, then the sample will give the complete information about the population. So with the minimum of effort, minimum of time, we can be able to come to the conclusion about the population. With the estimate, also accuracy of the estimate based on sampling. That means it will not be 100% accurate because we are studying only a part. Always there is a risk. What type of risk? The characteristics of the sample may not be same as the characteristic of the population. There may be some difference. That is called the risk attached in sampling. So we have to keep a limit. We have to fix a limit. What is the risk we are taking in giving the opinion about the population based on the sampling. Now, sampling is a study. Finally, I am saying sampling is a study of the part of the aggregate of the universe. Sampling is a study of the part of the aggregate, total, so as to formulate an inference about the entire universe. Why we are studying only a part? To give the opinion, to give the inference of the whole population. Then statistic methods provide a scientific approach. Now see here, this sampling is not a new concept. The scientific method of sampling has been arisen during the last few decades, but the concept of sampling is very old. Sampling was used by the people since a long period of time, but the scientific method of sampling has been started during the last few decades. Example, in our personal life, we take a number of decisions on sampling. When we go to buy a bag of rice or some commodities, we'll take a small sample from the bag of rice and we'll see the small sample to take a decision whether this bag of rice should be purchased or not. Similarly, other commodities, if any other commodity like pulses, etc., before taking a decision of the whole bag, we take only a small part and see. If the small part is good, satisfied, we'll take the whole. This is sampling. Similarly, in our household, the women normally when they cook food, they'll taste a small part of the whole and decide whether everything is okay or not, whether it is equally tasty or not, whether the salt, sugar, everything is good, appropriate or not. That means the women is taking the decision on the basis of sample. A small part is selected and give the opinion about the whole. Like this, when a person go to buy grapes, when they go to buy the grapes, they will taste one or two grapes. If the grapes are sweet, then the buyer will take the decision, no, the grapes, all the grapes are good, I will buy the grapes. That means the person, the consumer, the buyer is taking a decision only by tasting a part and taking a decision of the whole. In this case, we are not applying any scientific method. If we do not apply scientific method, what will happen? The risk of our decision may go wrong will be high. The risk that our decision may go wrong will be high. Example, when we go to buy grapes, we are testing only one grape and deciding that the whole grapes are sweet, are good. It may happen that whatever he has tested, that is good. That after that, the other grapes may not be good. That means his decision may go wrong. So this error what we are deciding on the basis of sample is called standard error. Standard error means the characteristic of the sample will not be same as the characteristic of the population. That means our decision is going to be wrong. That is called standard error risk. Statistical methods provide a scientific approach in selecting an appropriate sample. So scientifically, statistical methods are available through which we can study, we can do sampling so that the standard error will be minimum. That means our risk will be minimum. So how the risk will get minimum? By applying the statistical methods. Different methods have been specified by statistics through which the standard error may get reduced. That means we'll get maximum information about the population from the study of the sample. In selecting appropriate sample and making inferences about the universe from the study of such sample. So that is the main purpose. So sampling is an old concept, but the statistical methods which are applied in sampling are new one. The purpose of applying statistical methods in sampling is to reduce the standard error risk. To reduce the risk of sampling, we are applying these statistical methods. So this is the complete basic explanation about sampling. The next topic is parameter and statistic. These concepts you should remember because while doing the problem very frequently we come across parameter and statistic. In examination also theory question may be asked, what are parameters and statistics in sampling theory? The parameter are the statistical measures of the population. Statistical measures of the population are called parameters. Example, population mean, population standard deviation, population proportion. These are called parameters. Similarly, the statistical measures of the sample. The statistical measures of the sample are called statistic. Example, sample mean, sample standard deviation, sample proportion. These are called statistic. So, the following notations are generally used to distinguish between statistic and parameter. While doing the problem, you may get the information about the population or you may get the information about the sample. So how to distinguish the statistical measure of population and statistical measures of sample? We are giving different notations or symbols. So what are the symbols that are used? Mean. We are having the mean of the population and also we are having the mean of the sample. So to differentiate, we are giving different symbols. What are the symbols? The X bar is the mean of the sample. X bar is the mean of the sample. Sample or statistic. Sample is statistic. Parameter is of population. Right? The mean of the sample is denoted as X bar. And mean of the population is denoted by mu. The Greek symbol mu. So X bar is the mean of the sample. Mu is the mean of the population. Similarly, standard deviation. Small s is the standard deviation of the sample, whereas sigma is the standard deviation of the population. So when standard deviation comes, you have to think whether it is the standard deviation of the population or standard deviation of the sample. If the population standard deviation is there, put sigma. If sample standard deviation is there, put small s. To differentiate. Then proportion. If the population proportion is given, write down capital P. If sample proportion is taken, take small p. That's all. These are the different symbols or notations used for parameter and statistic. Parameter are the statistical measure of population and statistic are the statistical measure of sample. That's it. Next comes statistical procedure. Procedure means what are the steps to be applied when conducting sampling. If we are applying sampling technique, that means scientific method of applying sampling, then what are the procedure? What are the steps? The first step is objective and scope of survey. Before conducting this sampling theory or sampling process, the investigator must be clear regarding the objective and scope of his survey. Why I want to collect this sampling? What is the purpose of making this sampling? The aim and objective should be clear before conducting the sampling. Otherwise, what will happen? Irrelevant data may be collected, which is not at all relevant for our study. Time, resources will be wasted. So always the investigator should be focused on the objective of the survey. Precise, clear objective should be defined. Secondly, defining the population to be sampled. Depending on the objective and scope, the investigator has to decide from which population we have to collect the sample. What is the population? What is the population size? That should be defined. So secondly, defining the population. Then the frame and sampling units. Once the objective of sampling and population size is decided, the third step is to decide the sampling units. First of all, we have to see whether samples can be precisely taken up from the population. There should not be any ambiguity, confusion regarding the samples to be drawn from the population. So sampling units should be very much clear. Then data collection. After that, 3 steps. The next is data collection. The investigator has to start collecting the data which is required for our sampling technique. Then collection of information. Once the data is collected, the data should be processed. By applying some of the statistical methods, the data should be processed and converted into information. Then selection of sampling design. Sampling design means sampling plans. There are different methods of sampling plan, like random sampling, non-random sampling, simple random sampling, stratified sampling, or scientific random sampling. So different sampling methods are there. The investigator has to decide which method, which sampling design is applicable. So every sampling method will have their own advantages and limitations. So investigator must know what are the different methods of sampling, taking the samples. Then field work. Once the sampling design is fixed, then field work. A team should be made by the investigator to collect the data, to collect the relevant data through different methods like making a questionnaire or making tables. Like that, different field work has to be made. The field workers should be properly trained to collect the information only relevant for our survey. The next one is pilot survey. Once the data is collected, we'll make a pre-test, initial test to see whether it is functioning properly or not. What is the scope, what is the objective of our survey, how we have collected the data, and we apply some procedure, then we'll see whether it is working properly or not. So some pre-test will be conducted on the data. That is called pilot survey. Lastly, summary and analysis. Once everything is collected, then analysis will be done. Properly data should be collected, it should be tabulated, and statistical methods should be applied. Get the information, make the summaries, give the recommendations, give the conclusions on this survey. That is the last step. Summarizing, analyzing, and interpretation is the last step in sampling procedure. So these are the steps, 9 steps to be applied in sampling. This is called sampling procedure. Next one is methods of sampling. Broadly, we divide the methods of sampling into two. That is random sampling or probability sampling, and secondly, a non-random sampling or judgmental sampling. Both the methods are equally good. It depends on the person for what purpose we are doing the sampling. What is the nature of data? On that basis, we have to select any one of the methods of sampling called random or non-random. The random sampling is also called probability sampling, and non-random sampling is also called judgmental sampling. So what is random sampling? In random or probability sampling, all the items of the population has the chance of being chosen in the sample. Every item of the whole population has equal chance of being selected in the sample. Every item in the whole population have equal chance of being selected in the sample. That is called random sampling or probability sampling. The non-random sampling or judgmental sampling, personal knowledge or opinion are used to identify those items from the population that are to be included in the sample. That means judgmental sampling means the investigator has the power to decide which are the items of the population should be selected in the sample. That means every item of the population do not have equal chance of being selected. It depends on the person, investigator. The investigator will decide which items of the population should be selected in the sample and which items should not be selected. That is called judgment. He is applying his own opinion in deciding the sample. Then a sample selected by judgment is based on someone's expertise about the population. If the investigator is having good experience, expertised knowledge in selecting the sample, then we apply judgmental sample. So this is all about random and non-random sampling. The next thing is sample size determination. See, if you want the complete information of the population, the sample size should be adequate. If the sample size is wrongly taken, then definitely our conclusion, our inference may go wrong. So ultimately the whole process, the whole conclusion depends on the size of the sample. The sample size should neither be too small nor it should be too large. Example, if the sample size is taken very, very small, then the risk that the characteristic of the sample and the characteristic of the population may be different. Risk will be high. So it should not be too small. If the sample size is very, very large, then what will happen? What is the purpose of doing sampling? We can go for population itself, census itself. The main objective why we apply sampling is to reduce the time, reduce the effort, reduce the cost. So if you take a huge sample, then what is the purpose of doing this sampling? That means it should neither be too large nor the sample size should be too small. The sample size should be adequate. That means the sample size should be such that we can get maximum information about the population. That's it. So in this video, I have explained you the basics of sampling. Then I have explained you about parameters and statistics. Then sampling procedure, methods of sampling. Lastly, sample size determination. In the next video, theory video, I'll continue regarding the remaining part like sampling distribution, standard error, central limit theory, hypothesis testing, and estimation, point estimation, interval estimation. All these things I'm going to continue in the next video.